In this video, we solve problem 8.R.021 from the Larson and Edwards Calculus Early Transcendental Functions text, 7th edition. We're asked to evaluate the trigonometric integral, and we're asked to use capital C for the constant of integration, and we have this right here. So I've got a secant to the fourth of x over 8. Now, the first thing that I would do if I didn't know exactly how to start this problem is I would look at this integral and then I would think about the trigonometric integrals guidelines for powers of secant and tangent. You'll have access to those on your exam if you're taking my class for a problem that looks like this. So let me show you what that looks like and where to find how to start this problem. So if you go to Unit 1 exam information, well, if you go to Unit 1, you can find materials for evaluating trigonometric integrals and evaluating integrals that require trigonometric substitution. If you just click on this folder, then you can find the handouts that are associated with that. And if you scroll all the way down, it says you'll be provided with this formula sheet during exam 1. So you can find the reference sheet for trigonometric integrals in the Unit 1 Lesson 3 folder. You can also find that document directly at the Unit 1 exam information link right here. So I go here and then click here, and then you see your 2 reference sheets. So you'll have access to this during your exam. And we know we're dealing with a secant to the 4th power. So we're dealing with powers of secant and tangent. The guidelines for that are on the 2nd page. And we've got a secant to the 4th. So the power of secant is even and positive. So we're going to start with the substitution. U equals tangent of our constant times x. And then we're going to save a secant squared of that constant times x as a factor for our du. So if you do not know where to start, always just go to this sheet and it will tell you how to get started. Okay, so we know we're going to let u equal tangent of kx. The kx in this case is x over 8. So I want u to equal tangent of x over 8. And then we want to compute du. Derivative of tangent of some angle is secant squared of that angle times the derivative of the inside by the chain rule. We can think of that as a 1/8 x. The derivative of 1/8 x is 1/8. And then du is that derivative times dx. And we don't actually have a 1/8 factor up here, so I would multiply both sides of this by 8 in order to get that secant squared of x over 8 dx by itself. Okay, so we're told that this is the approach to take. We start by defining u. We compute du. And the guideline said save a secant squared factor for du. So we'll have secant squared of x over 8 times secant squared of x over 8 dx. So this is the part that we'll write in terms of u. That's 8 times du. Now everything else in here has to be written entirely in terms of u. Now we can write secant squared in terms of u or in terms of tangent by using one of our Pythagorean identities. Excuse me. Remember, if you have 1 plus tangent squared of an angle, that's the same as the secant squared of the same angle. So this is 1 plus tangent squared of x over 8. And since u is equal to tangent of x over 8, this is actually a 1 plus u squared. So now we can take this and write this integral entirely in terms of u by factoring out the 8. Then we have a 1 plus u squared as our integrand times du. Okay, so now we just antidifferentiate this, and then don't forget to back substitute. The antiderivative of 1 with respect to u is u. The antiderivative of u squared comes from applying the power rule. We add 1 to the exponent and divide by the new exponent Don't forget to add your constant of integration. And then of course, we don't want an answer in terms of u, we want an answer in terms of x, so we need to back substitute. Remember what u is. U is equal to tangent of x over 8. So this needs to be replaced by tangent of x over 8, and so does that. If you want, you can distribute the 8, and I do want that. And then I just replace my u with tangent of x over 8. And then we have the convention that when we are taking a trig function and raising it to a power, we usually write the exponent on the name of the trig function. Now, one step where students tend to get tripped up is when they go from here to here. They might see that 1 and think that the antiderivative of 1 is x. The antiderivative of 1 is 1 times the variable, and in this case, when we're taking an antiderivative with respect to u, the variable is u. So that's why I have a tangent of x over 8 here as opposed to just an x.